I didn't have to go watch it. And she does, I told her, your face, and she does. They like it. Yes. Oh. Yeah. And that's what he had. He never got. And so. Well. What did you say? I don't know. So I heard this.
Can you try it? Perfect. Okay.
Little bit is usually circles. Looking up like way. I always look
Good evening, everybody. Have your attention, please. Want to get started with Mike's presentation. He's going to talk to us tonight about the rehabilitation of the Daly Judge Tunnel, the 2002 Winter Olympics. His involvement in that project to ensure continual water supply. Just a little background of Mike. He's a senior mining consultant at Stantec Engineering, and when I worked at Rio Tinto Kennecott, we actually use Stantec quite often, so familiar with the company. He previously taught mining engineering at University of Utah. He worked in the mining industry for Kennecott Copper, Consolidation Coal, and Ironcoal Processing Equipment. Mike's dad grew up on Ontario Avenue here in Park City and worked at the Silver King mine while he went to college. His grandfather also worked at the Park City mines for over 30 years. Whenever he wasn't laid off from strike, was he a tramp miner? When he had to be, okay. Putting food on the table. All right, Mike is a distinguished member, fellow of the Society of Mining, Metallurgy, and Exploration, otherwise known as SME. In 2020, he received the General Patrick E. Connor Award for service to Utah's mining industry from the Utah Mining Association. Without further ado, Mike Nelson. Thank you.
Well, you can see here, this is an old picture of the building at the discharge of the Daly Judge Tunnel. I put this in because I was up there with my dad before he passed. He said, I remember coming to that building with my dad sometime in the 30s. They said, let it be known that they were hiring miners. There was a big line of men lined up in front of the steps. And each man, the super was on the steps. Each man would walk up and stand there, and the super would either gesture with his thumb, and then go and get your gear on and go underground, go like that. And you didn't look strong enough. That was the only criteria. I mean, seriously. So he remembered that. But we all know, I think you're familiar, Park City was very wet mining district. There was a lot of water everywhere. And the miners used to tell stories about the man in the yellow slicker on the mines, kind of the equivalent of Orange Tommy Dunker. But I think we've talked about this before. I have. This is interesting because at one time this was the biggest pump in the world. It was brought in to pump the water out of the Ontario mine. You can see the details on it. It was a huge pump. Just to give you an idea, it ran on steam and burned 127 tons of coal a day just to let water out. That only got down to the 600-foot level. More was deeper than that. And so they built another tunnel for the Ontario. And in 1887, they built one for the Daly Judge. It was started in August on the 1200 level. And you can see the details there. Originally 6,600 feet, it's now 10,000. Had 7-foot posts on the timbers and a 5-foot sill. Let's see if I like that. And it had a grade of 3/4 of an inch to a rod. Anybody know what a rod was? Old time, what's that?
20 yards?
It was a surveying device that was 16.5 feet long, right? And there were 4 rods in a chain and 80 chains in a mile.
Good to know.
And just for interest, that's what a surveyor's chain looked like in those days, right? And that's how they would, those links were each very carefully made by the blacksmith and joined together so that that chain gave a very precise measurement of distance. And that was very important in surveying. So to develop the tunnel, they used 3.5-inch Ingersoll drills and dynamite. So they're drilling holes, loading them with dynamite, blasting. And those drills would have either been steam or air, depending on the time. Okay, so they weren't drilling by hand. The total cost of the tunnel, they could go about 15 feet a day. They didn't have all the problems in the Daly Judge tunnel that they had with the Ontario, with that real problems with ground control, things caving in, water, you know, that knock people down.
Sorry, just a quick one, were they Widowmakers or when did they have water?
With drills, I believe they had water on the pipe, but probably not reliably, you know. Because miners' consumption, as they call it, was still a big problem until about 1910 or 15. And, you know, the total cost at that time was $200,000. That's about $7.5 million today. Now, later it was extended, had a lot of branches, and it passes near the Daly West shaft and the Judge number 2 shaft, and that's important because the tunnel could be connected to those shafts and then people could get around that. And there are all kinds of side drifts, and horseshoes, and winzes, and stopes, and all those words. You can only see in crossword. Adits, I forgot to say adits. And it also passes through 2 major faults. So you can see the timbering design here. Is that mic picking up better now? So this is called the sill, 5 feet across, and these are 10 by 10 inch red pine timbers. Underneath was a water ditch. Miners had another name for it. And then these tapered up to a 4-foot cap, and these boards alongside were called proper. People call them the lagging. The miners called it the lag. And those were 3 by 8 or sometimes 3 by 10 inch slab, and they were just nailed or attached to the backs of the big timbers to keep the loose rock from falling here. Because you can see just barely down there, there are tracks here, the 20-inch track there. Mine, it's important to keep that clear. So that gives you an idea, and you know, you think a 10 by 10 inch timber that's 7 feet long, how much does that weigh?
100 pounds?
Couple 100 pounds, right? So, you know, and then that sill, how did they get that in there?
All by hand.
Did they bring in the Bobcat and it's,
Yeah.
they didn't do that, okay? Typical miner at that time was 5'8", 5'9". So what they would do, this is interesting, after they blasted around and that ore would be piled up there or the rocks, they would take enough of that down that they could work up on that pile to raise these timbers in place. But at some point, you know, a couple of guys just had to lift that cap place. And it was hard work. Timbermen were among the highest paid. So the Daly Judge Tunnel provides about 25% of Park City's water supply. It's maintained, it was maintained by United Park City Mines until 2000. And when United Park City was bought out, it's now maintained by the city. And the water quality is really good. This is water that's been underground for millions of years. Comes out cleaner, would meet every EPA standard you can imagine, unless there was a roof fall. And what were they mining in all of these tunnels? Lead, zinc ore, the silver and gold in it. Guess what else comes along with lead, zinc ore? sulfur, arsenic, cadmium, all those volatile heavy metals, okay, and so they're kind of in the dust. So not in a lot of, not in a high concentration, too high for drinking water. So what's in the dust? That became a question. And the people in Park City at the time in 2001, they're planning for the Olympics, and they said that their procedure was up until about 2001, if there's a roof fall in the Daly Judge or in the Spiro Tunnel, we just won't use that water for a while. Okay. Hardly ever happened, but they didn't want to have that during the Olympics because there'd be a lot more people there. You know, it's good planning. So they knew that the timber sets were deteriorating. And so they got in touch with me and a fellow named Ben Signor. I don't know if running him. He's 20 years older than I am. So, but he was a mining engineer with a lot of experience, and they asked us to come and take a look at it. So there's another picture there, and you can see our job was to sit on that orange car that's called the Camelback. The miners would sit on that, and then it's pulled by an electric motor in front now, and just go in and take a look at what was going on. Just to give you a little appreciation, Park City water system is very complex because of where the water comes from and all the difference in elevation around the town. So there are two treatment plants. There's a new one out by the Spiro Tunnel, which many of you have seen there. One at Quince Junction, 16 reservoirs. They have a storage capacity of 14.5 million gallons. There are 8 culinary sources, 3 deep wells, 2 tunnels and a spring, and they can import water from the Jordanelle Special Services District if they need to. And then they got 43 pressure zones, 20 tanks, 16 bunches, you know. If you can imagine, you've got this big system of pipes going all over, and nobody wants to turn on the tap and have nothing come out. And nobody wants to turn on the tap and have come, you know, you want to steady pressure in your culinary water system. So it takes some good management. This is the Spiro Tunnel now. I'm sure many of you have been up there. It was remodeled extensively in the last few years, which we did because it was in bad shape. So that kind of summarizes this picture of science. You can tell if you're interested in sign painting, that's all. Right, by somebody with a pretty steady hand. Too far. So we agreed, we signed a little contract with the city to inspect the tunnel, document the conditions, recommend corrections, and then locate a contractor and monitor construction to replace these tunnels. The timbers that were deteriorating. And this is what it looked like going in. You can see that they've already put in some steel sets, as they're called, where the timbers were failing. And that's to keep the roof from caving, right? You can also see this stuff between here and the Ontario. I lost track, but I counted at one time 32 different types of fungus that I counted. And I'm not a mycologist, you know, just by their appearance. So there was this stuff, and the miner said, "Don't touch that, and burn your hands." I believed him, I didn't try it out. But these timbers were all dry. So before doing this job, and you know, we always now in mining and any other hazardous occupation, we do a risk assessment before we start. What are the risks? We're in this tunnel back 6,000 feet. What if the roof caves in? Is there any other way out? Turns out there was. Had to climb a 600-foot ladder, but there was a way out. What about a flood? We weren't too concerned about that because there's so many side drifts there. What about asphyxiation? You know, if there's a roof fall, you're going to be shorted with oxygen. What if the battery blows up? They do that, and then the pumps. So we looked at that, and we decided roof falls unlikely. There's chaff, inundation unlikely. We did have an oxygen meter with us to make sure that the oxygen level stayed up. Inspected the battery every shift to make sure it was clean and well protected. And touch the fungus.
That 600-foot ladder, what shaft was that in?
I can't remember. Either number 2 or number 1.
Okay.
Okay, so we went to work.
We haven't seen everybody with that clicker.
So we went, okay. There's some more of the fungus, that's in the Ontario tunnel, but you can just see their weird stuff. So this is a sketch map of the tunnel that we made, and this is the results. You can see we shaded it in and said, the purple is, it needs immediate attention. That goes 1 year, 5 to 10, 10 to 15, 20 or more. So there was a lot of work required. And you can see that some of these old side tunnels. So the details here aren't important. We just made a note as we went along. We stopped and inspected every timber set. We had a very sophisticated instrument doing that. Screwdriver, and all you did was push that against the timber, and if it went in more than 2 inches, that timber needed replacement. So. Actually, I provided that from my familiar. So we made a list of all the timbers that needed to be replaced or modified, and that was on that big spreadsheet. You couldn't read, but there were 69 timber sets that were failed. See it? There were 100 lagging sets needed replacement. They were blowing out. They, if they start giving away, these things are all connected. And we estimated that there were about 102 cubic yards of muck that have to be moved. As they take out that lag, muck falls in. You want to keep that water ditch clear so the water will flow out. So these are some nice photos of 10 by 10 timbers failing. Okay, those of you, if you have some engineering background, wood's really strong in compression, right? And there's some compression there, and those 10 by 10. You look at those. So, and you can kind of see the lagging behind them, especially there on the picture on the left. And that lagging was an important construction material if you were mining in Park City. You could use it to reinforce the root cellar. When there was a big snowfall, and the path shoveled out to the street was about 8 feet high. You could just put some lagging over the top of it. So, and they do that. Well, the plan was to replace the failing timber sets with twin steel sets. Twin means we didn't take out any timber unless it fell out. We just put in steel right next to it. And it was basically the same size as what was in there, steel. And then you can see the details and how it's bolted together in place. One advantage to this was that this could all be fabricated on the surface and then it's taken in like a big erector set. And then the lagging still had to be installed. So that was the contractor's rates. We contracted with a company called Miners Inc. Contract mining. These guys were real tramp miners. Some of you probably knew Gary Stubblefield, who worked at Norwest. Anyway, his brother John was there. They'd grown up in Tintic miners. Their dad was a miner. Okay. So they knew their way around. In fact, I asked John Stubblefield, I said, John, what are you going to do when you get through here? He said, well, I'm going down to that salt mine in Louisiana. We put in all the roof bolts that are more than 100 feet up. And it is true, in those salt deposits, they're really stable. You can find that. I said, how do you do that? He said, oh, in a cherry picker. So if you've worked in a cherry picker, you'd like to be up 100 feet. He said, problem is you can only do one bolt, and then you've got to move it. It's up that high. So interesting job. So this is their bid to give you an idea. They said, the superintendent was $76.50 an hour, and they planned it out carefully. And this company was vintage enough, and there was a time when this was all printed out. Email it to us. And they charged for everything. It looked like a reasonable cost, and their markup was only 18%. So there they are, ready to go to work. That's John Stubblefield in the middle, and the chief timberman on the left. And that's my dad with him there. I arranged for him to come see it today. He hadn't been underground in 50 years. As you can tell. So what failure modes did we consider? Failure of the posts in compression. There we go. Failure of cap timbers in shear, failure of the cap timbers in compressions, contact with the post. We had to do an analysis on what was here to see if the steel would really adequately support the loads that the wood received. So we did that with the standard handbooks and steel construction with handbooks, and thanks to the professional association, government, the state is all available. And this is from a technical paper I did. But we compared the strength of the timbers with the strength of steel. And you can see the timber strength, if you just look at one of them, and this was for Canadian publications, so everything was killed. Anyway, for the axial loading of the post, they could tolerate 941 to 2,000 kilonewtons. And that was a lot higher than the steel. But then we talked, we reviewed it with some structural engineers, and they said the ratings for steel beams are derated by a factor of 5 or 10. Okay. In the wood handbook, they don't do that. So, and the fact that the United Park City Mines put some steel sets in there, they were holding up real well. And that comparison took us to the point where we felt okay about it. Now, is that good engineering? You'll have to answer this. But support of an old mine tunnel like this is a lot based upon experience and creation. There's just a lot of things you can't measure. Well, the timbers, and that was acceptable to the structural engineer, and decided to do it. Also, you can see that we had a choice of using 6 by 15, 6 by 20, or 6 by 25 inch I-beams, depending on how the ground looked when they took the lag. So there again, it was good to have people like John Stubblefield, who had 40 years of granite miner experience, say, this looks like. So again, there's what it looked like. See, it really looks just about like the wood timber set with the steel beams in place. Required hardly any change in the water ditch other than just cleaning it out. That stood up real nice. There. So results, project finished on time, slightly under budget. It turned out we installed 83 steel sets and 4,175 square feet of lagging. And interesting, they got that from the sawmill campus. They removed a lot of muck, and they cleaned the water ditch and deepened it spot. I put this picture in because it shows a whole bunch of little stalactites growing. You can see it. Just that, you do a job like this, and ever since I've worked here in the Ontario, I wish I took about 3 times as many pictures. But when you're doing the job, okay. So I wrote a little report to summarize it for the city. Furthest point in was 6,288 feet from the portal. Lagging was installed on the right-hand side, top of the tunnel at that point. We didn't place the support timbers, just the lagging. There's a lot of work around 61 feet. Old timber sets were backed up with steel sets on both sides. The timbers taken the filter, doubled it up. And the old timbers were not removed, but were left in place to be removed later as the weight transferred onto the steel sets. Because, that timber taking load was wedged in there. So to get the steel in, there had to be like 1/2 inch. And they said this is safer and it will reduce the amount of debris. There was a load around the old horseshoe at 5,952 feet. And if you don't know what an horseshoe is, I got a nice picture of one here. This is just, miners were probably stoping out on an upper level out here and they mine the ore. Would come down this horseshoe into that part with out of the mine. And if some of the ore chutes were set up with a door that you could put in to block them. so the miners could keep blasting and caving more down. And then the car guys would have to pull that blocking, that piece of board out. And let the truck. So very sophisticated. But, you know, it's interesting how much wood is used. Everything you do is made out of wood. And the other interesting thing is that all of the mines had extensive carpenter shops to get this wood ready. Now it was used. And anybody ever been to Virginia City? Nevada? Yeah. Okay, so those were the most extensively timbered mines that were used. They used a method called a square set, which is kind of like Lincoln log. The ground was so soft there they couldn't hold it at all. And some young mining engineer came from Freiberg, Germany, said, we could build half timbered structures underground like they built houses in Europe. They finally designed this system where everything was just came in all notched and ready to fit in place. They put it in place. And I could see a drawing of that. It worked really well. And they did that. The ground wasn't as loose here, so they didn't have to do it as extensively. But the less work you had to do underground, the better. So I said, whenever you have to work underground, it's going to be cold and wet, dirty and miserable. That's how we love it.
It's not you, it's the click.
There, okay?
Yep.
And, when the director of the water department came and inspected it, she came along the city, but they were concerned about, there was still some sawdust and debris at the bottom of the water tunnel with the water passage. They were concerned about that, but after about a week, it was all cleared out. So that tunnel stood up nicely during the Olympics. But the city will want it. I don't know if they've been maintaining this personnel change, so on, but I expect they have.
The Jordan Special Services maintains it.
That's Martinez.
Hey, Brian, actually, I was told that the city maintains it.
Oh,
When we did the tour of the new water treatment facility, I thought it was JSSD, but
at the judge.
with the judge. And when you hike up there, you'll often see the railroad engine
Yeah, parked out.
parked outside. People working.
Is that at the starting end of the tunnel? Up in
Yeah,
Empire?
it's by the judge's office.
I didn't mention that, but it started in, let's say, in Empire Canyon across from Walker Road. It started, and then it ended out there by the road. Goes down to the old Ontario. Probably still right up there. So that's the conclusion of my presentation. I'm happy to answer any questions. Try to.
Hey, Mike, when you were in the tunnel in 2001, how did they ventilate it? Was it coming down the Daly West shaft? Air?
It was always natural ventilation.
So now that the Daly West shaft is plugged, what do they do for ventilation now, do you know?
I don't know. I know that, the old literature said it connected to two shafts. I don't know, I don't remember which.
Well, the anchor shaft is also plugged,
Is it?
and
Because this was originally anchored.
yeah, and the anchor shaft was plugged a long time ago, and the Daly West got plugged in 2015.
That's a good question.
Yeah.
I don't think the Daly West is plugged. I think it has it closed up and there's an opening
There's
for
another.
flood air in.
No, it doesn't go through the plug.
And I recall at the time they were lifting the shaft up, somebody saying that there was going to be a venting.
They put that 3-foot diameter culvert through the path that they put in. And it goes down to the debris plug that plugs the shaft. And the intention was to monitor what's happening in that debris plug, because if that ever lets loose, that could destabilize the cap.
That's what I heard.
I just say one more thing about that. When we first went in to inspect this, started the job, we took an oxygen meter. And, I mean, natural ventilation just depends on convection, right? And depending on the ambient temperature, twice a year it changes directions. Okay, and we're right at that time when it was changing direction. So that there was still air moving in the main tunnel, but if you got off to the side, well, the oxygen meter got down to 18%. And that's not recommended. Okay. It didn't bother me at that time, but Ben, older than I am, and sturdy fellow, he's a big guy, right? And he was breathing hard. He's got to go back up. Yeah.
I just want to tell a funny story. In the early '70s, when the water came from, the Daly West, and then down in the old town. We had friends that lived on Sampson Avenue, which is the highest point, the little town. They had to take a shower at 4 in the morning because there was no water for just like 8. So, anyway, it was a pretty sad system.
Yeah. Yeah.
Yeah, what about that, community fungus? Is it all over the house?
I mean, it's on a lot of the old timbers. And I thought, it'd be interesting to get somebody who specializes in that. Pictures of it, figure out what it is.
So wherever the wood timbers were, the fungus was like.
Where the wood timbers were and where there was enough moisture in the air, that was my technical observation. But fungus is very opportunistic.
It grows on wood.
Yeah.
That question, you mentioned there was, you identified 60 drain sets. How many were the total sets? What percentage roughly of the total? Was that?
So I think they replaced 89 as they got in there. They replaced more than most that we identified.
But how many total were there that you didn't need to change? You remember?
Well, let's see. So they were originally 5 feet apart and it was 6,600 feet.
So it wasn't that many.
It's not that many. The thing is that, the most of the replacements were in concentrated areas. Because there's all kinds of variation in what's going on above that tunnel, and it's loaded differently. So, it wasn't definitely maybe 20% of it.
Those timber sets, were they original? The ones you were replacing, were they original or?
Some of them you could tell were original, some of them have been replaced. It's interesting in that tunnel and in the Ontario, and the miners that worked for us today, they signed an initial. I mean, so-and-so from Coeur d'Alene, Idaho, they got back in the back of the Ontario tunnel, looked at that, and those miners, some of them, they've written on there, you have a carbide lamp up close to the timber, you've seen that, right? So, see, that's a picture I wish I'd taken.
Yeah.
But, so, and when, it's interesting because the posts and the caps were all cut on the ground, but the lagging has to be sort of custom fitted. The miners did that underground with I call it a buck saw or a bow saw, they call it a sweet saw. And they were really, and to get that in, I mean, you think, oh yeah, you put up these 10 by 10s, and then you put 3 by 10s behind them. So you put them in like this, how do you do that? It's not immediately obvious, it's a skill. And if you look at the pay scales from the old mine records, even timbermen have their own pay scale. And as they finished, for example, the Ontario tunnel, Green Park record, it says that last timbers were installed in the Ontario drain tunnel number 2. Last Saturday, 23 timbermen were released. So those guys had to try and find, right? Find them.
Hey, Mike, when you were in the tunnel, do you recall when you guys found the station for the intermediate shaft, that when they drove the tunnel,
Yeah,
about halfway along the length of that 6,600 foot long tunnel, they sank a shaft so that they could run headings
either way.
either way. And so they ran 3 headings to drive that tunnel. And I would think that there'd be a kind of lost track of where that shaft would have been.
Yeah.
And I wonder if your notes saw the station, you know, where that shaft intersected the tunnel.
I don't remember seeing it. Oh,
Yeah, okay.
And I was not as aware of the history of all this at that time.
Yeah.
I mean, this job, looks at the Ontario tunnel, #2 tunnel, because the Sandy, South Jordan Water Conservancy District was thinking of buying some of this. So they asked me and the geology professor to look at it and say, how, what's the condition of this tunnel? Is it going to require a Any other question?
How long did the project take?
It took about 2 months.
This is 2 months, okay. And how far ahead of the Olympics did you complete it?
We completed it, I believe just before the end of the year, 2000.
Okay.
So in good time.
Good.
Yeah. It was, I think, the city did a good job of managing that, and anticipating a risk.
When you were doing the job, was the Daly West shaft still operable? Was that one of your escapeways?
It was sometimes, it's not a reliable escape.
Even then.
So what, 10 years into the future, then the mine maintenance tasks will have to be done for the 2034.
Well, I mean, it should certainly be considered. And, from what I hear, those tunnels are being more actively maintained now than they were. I mean, even, we did an analysis of the Spiro Tunnel in 2014, and there were 3 men working in there every day. But, they were just barely keeping up. There was an area where a lot of rock was really soft and loose, and they put in roof bolts with chain link to support it. And I told my buddy, said, that chain link looks like the buttons on a fat man's shirt. Pushing the chain link. And then the other big concern there was that to the back of the tunnel, I have to and said, well, there was a dam back there, 3 feet. That, it's kind of retained some water for storage. It was made out of, looked like original timbers. And that dam failed, that water. First off, those miners, then you think, where would all the water go, out of the Spirit Tunnel? So that was the recommendation.
Where was the dam, Mike? I didn't hear that.
It was just almost back beyond the shaft that went up for the ski lift.
That's the plan, yeah.
Got a picture of that.
Yeah.
And, I think almost every little kid's fascinated with tunnels, right? Playing with tunnels, playing in water. So I kind of had a neat job.
I haven't noticed, has that creek down in Empire County, is that dry now? Is it still water flowing?
It will be seasonal.
Is that just seasonal now? It's not perennial?
With new water treatment. that's
Yeah,
Seasonal stream, which is what it was originally.
right.
Drain Creek Tunnel you're talking about?
No, Lower Empire Canyon, the creek that comes out of the, downstream from the tunnel. For years, it was perennial because they were letting water from the tunnel go down the creek. Now they don't do that anymore. I had read, I haven't been.
That's from the Daly trailhead, right? You're talking about that stream?
Yeah.
Stream.
Up at the top of Daly Avenue, you
Yeah.
go up, yeah,
That's now supposed to see.
that's just, if I'm right, okay.
You mentioned when you put the steels in, you might have taken the timbers out at some later date. Did they ever do that?
Not that I know of. I think they probably, as long as they were intact, and not decaying into the water, probably no reason to.
Might be able to, lease it out for a fungus.
Mushroom.
Mushroom.
Well, I know there are mushroom farms. That's right.
Yeah.
I guess, well, subject that you might be interested in, what the ladies on Heber Avenue told my dad when he started delivering papers. Everyone knows what Heber Avenue was, the red light district.
Yeah.
He said that one of the ladies called me in. His name was Tom. She said, Tommy, you're a nice boy. I know your mom. She treats us with respect. She says, we're happy to take the papers from you. But you get older, if I ever see you come in here, I'll go to your mom. Yeah.
On the timbers inside the mines.
Yeah, they do it, probably in the old days with a piece of charred wood, I would guess, And I think the new guys in 1981 had a Sharpie. Well, that's one of the, and seem to be highly motivated, leave their names.
Yeah.
Well, thanks for your attention.
Thank you.
Yeah.
welcome.
I don't.
Oh, yeah, yeah.
I remember when you touched it.